Exercise 7, find the values of x and y in the diagram. And we have ourselves a triangle which has an extra little segment in here from N to L, and it has some different parts of it labeled, and we want to find the value of x and y. So go ahead and pause the video, see if you can find the x and the y on your own, and then come back, unpause the video, and see if you got it right. All right, so for this particular problem, notice that over here on the left side of this diagram, we have ourselves an equilateral triangle. We know that it's an equilateral triangle because it's equiangular, right? By the Equilateral Triangle Theorem. So already, right off the bat, we know that y is equal to 4, right? So each one of these sides are 4. 4 and 4, and that one's 4. Bam, I'm halfway done. Easy. All right, and then the other triangle in the picture, this one, what type of triangle is this one? This type of triangle over here is isosceles. It's isosceles, but not equilateral. I know that because the two base angles down here are congruent to each other. So by the converse of the Base Angles Theorem, these two sides have to be equal to each other. So we've got x plus 1 is equal to 4. Man, do you remember when algebra was like this? It was just that simple. And then you were done with it. X equals 3. Okay, next. It's an SAT question. Find the value of x. See, you've got two stacked triangles in some kind of way. The value of x right up there at the top. Pause the video. Give it a try. Okay, so for this particular problem, notice that once again, we have ourselves an equilateral triangle. Look at this coloring. This is pretty fantastic. Oh, really? Okay, so I'm not going to color it. So down at the bottom, we have ourselves an isosceles triangle. And, not isosceles. It is isosceles, yeah. We have an equilateral triangle. I know we have an equilateral triangle because we've got 60, 60. The only thing that's possible to be left over is another 60-degree angle, which means that all of these sides are also the same by the Equilateral Triangle Theorem, which means that this side over here is 24. And then up here at the top, maybe I'm going to go ahead and give this a try of coloring this one in. Maybe I'll do a better job. Look at this. It's beautiful. Why did I color that in? I don't think it was absolutely necessary. Anyway, it was just for funsies. So notice I got a right triangle up here. And I can find the value of x by just using the Pythagorean theorem, which would state that 18 squared plus 24 squared is equal to x squared. And now it might be time for a calculator, but I think that 18 squared is 324. I think that 24 squared, 576. Let me double check. 24 squared. Yes. 576 is equal to x squared. There's 800. That looks like it's somewhere around 900. Somewhere around 900. Last step here is take the square root. Square root of 900. Well, square root of 9 is 3. This is going to be x is equal to 30. And in a future lesson, which I'm going to give you a sneak peek of right now, we can shortcut this a whole bunch like this. 18 and 24, they have a common factor of 6. This is 6 times 3, right? And 24 is 6 times 4. And what we're going to see is that the hypotenuse must also have that same exact factor. It's 6 times 5, because it's a 3, 4, 5 right triangle. It's just been scaled up by 6, and then 6 times 5, of course, gives us the 30 that we have right there. Nice. Okay, 9, another SAT question. What do you know? In the figure shown, if O is the center of the circle, what is the value of x? So we've got a circle, we've got 70-degree central angle right up there, and then there's the angle X marked for us. So go ahead and pause and give it a try. Okay, so for this particular example, we're going to mark that, hey, yeah, how about red? Yeah, that these two sides are congruent to each other because they're two radii of that circle. They have to be congruent, which makes the triangle in the picture isosceles, which also means that this over here has to be an x. So what we have here are two x's together plus the 70. All of these things have to total up to 180 degrees. So if I subtract the 70 over 2x is equal to 110, and x has got to be 55 degrees. Back that up. No, it's the wrong color. Everybody knows you're supposed to box your answers in magenta. Okay, one last problem, I think, also an SAT question. In the figure shown, if AB is equal to AC and AC is parallel to BD, what is the value of X? And this picture is all kinds of not drawn to scale. So I'm going to suggest that when you pause this video, that you mark the picture with the given information, which is going to help you figure out what the value of X is. All right, so let's do exactly that. Let's mark our information. It says that AB is equal in measure to AC. Doesn't look like it, but it says it. Not drawn to scale. That's a W right there. Take my word for it. Oh, really? The whole word goes? There we go. Not drawn to scale. And usually SAT problems, if it's not drawn to scale, they'll tell you just like that. All right, the other thing is that AC is supposed to be parallel to BD. Okay, both of those things are going to come into play. And we want to know what is the value of X. Okay, so notice that what we have here, right up here, is an exterior angle is 130 degrees. And that exterior angle should be equal to these two remote interior angles, blue, which are this one here at B and this one here at C. That those two angles, which I will, for the purposes of convenience, call a Y, those things have to total up to 130. 2y is equal to 130 degrees, which means that y is 130 divided by 2, which is 65 degrees. So we got a 65 there. We got a 65 right there. Okay, X, however, is not an exterior angle for that triangle. However, let me clean up my picture here just a little bit. This 130 degrees, even though it doesn't look it, is also congruent to this angle right here, all of this angle ABD, because those are congruent alternate interior angles. Because the lines are parallel. That was the reason why they gave us that second piece of information. Which means that X plus 65 is equal to 130, which means that X is equal to 65. Interesting. All right, these are going to clash terribly, this red and the magenta. Ugh. All right, just deal with it. All right, so that brings us to the end of this lesson on isosceles triangles, developing and proving some theorems about isosceles triangle. It was, we got the base angles theorem, which if the two sides of the triangle are congruent, then the two angles opposite them are congruent. It was also true in converse. If we start with congruent angles, then we can conclude the opposite sides are congruent to each other. And if we put those things together, we are able to conclude that every single equilateral triangle is also equiangular, where all of the angles total up to 180 degrees, and each one is 60 degrees.